In this video, I'm going to show you how to apply the fundamental theorem of calculus part 1 when the upper limit is not x. Suppose instead that the problem was to compute the derivative of the following function, where the upper limit was x to the power of 5. Now we can't apply the theorem as it is because the thing that we're differentiating, which is g of x, is with respect to x, and it doesn't match the upper limit of the integral, which is x to the power of 5. So in order to apply the theorem, we must also apply the chain rule. So I'm going to show you how to do that. And what we're going to do is we're going to take the d dx, thinking of that as differentials, and we're going to split it up into dx to the fifth dx times d dx to the fifth. So notice the dx to the fifth would cancel off, and we would end up with d dx. So I'm going to write the rest of this integral. And now I'm going to take the derivative. So dx to the fifth dx is 5x to the fourth. Now these match, so I'm just going to take the x to the fifth and substitute it in for the t. So now I have sine x to the fifth all squared. So simplifying this part here, I get sine x to the power of 10. So notice that when we apply the chain rule, we get the thing that we are differentiating with respect to x to the fifth, and these now match, so we only need to plug this in to the t value. And we couldn't do that before because this was x, not x to the fifth. So let's take a look at a couple more examples. So we're going to find the derivative. So this would say that I want to find dy dx, which means I'm going to say that on the right side, this would be dx squared dx times d dx squared, and the integral of 1 x squared cos t dt. So the derivative of x squared is 2x, and then the derivative of this integral is cos x squared. So this is relatively easy. You just have to remember to also apply the chain rule. So here again, let me go dy dx, and that is equal to d 3x squared dx times d 3x squared, so that it matches the upper limit, 3x squared 10, and then the natural log of 2 plus t squared dt. So here we get 6x times the natural log of 2 plus 3x squared squared. And just to simplify that part there, we get 6x times the natural log of 2 plus 9x to the power of 4. And that's it. That's how we take the derivative of an integral when the upper limit is not x.